Hey everyone, welcome back to The Explainer. Today we're unpacking a highly anticipated set of papers from Marie Soleil Sechot Landry, the CEO of Landry Industries. We're looking at what she identifies as a massive dual crisis facing modern AI. On one hand, we've got the notorious problem of AI hallucinations, models just confidently making up fake facts. But on the other hand, there's this massive hidden problem of computational bloat, where fixing those fake facts is costing an absolute fortune in processing power and energy. It's a truly fascinating look at how technical flaws create economic bottlenecks, and of course, the proposed architecture to actually solve them. So imagine you're using a state-of-the-art large language model to write a massive 50,000 token technical document. Everything looks perfectly fine, except the model messed up one single number in a crucial citation, just one typo. To fix that one error at the very end of the context window, the standard procedure for current models is literally to regenerate the entire sequence. That means you're paying computational costs for 50,000 tokens just to fix a single digit. You're paying a massive toll for a completely redundant generation. It's crazy. Okay, let's dive into this. Here's our roadmap for untangling this massive inference waste over the next few minutes. We'll start with the AI facticity crisis, explore the underlying sin of autoregression, and then unpack Landry solutions, the copy-paste protocol, surgical token patching, and neurosymbolic logic gates, before finally landing on the big picture, post-predatory AI economics. Section 1. The AI factivity crisis. 27%. According to the research, that is the staggering hallucination rate for citations when AI attempts to generate facts from scratch. Let's say you're generating the technical specs for something highly precise, like hempoxy's biomaterials or battery cycle lifespans. Over a quarter of the time, the AI is just drifting. It's generating statistically plausible but entirely fake data. And in technical documentation, a 27% failure rate isn't just a minor annoyance, it's a fundamental breakdown of trust. And that brings us right back to our second critical number, 50,000. When that 27% hallucination rate inevitably hits your document, you get slapped with the token tax. Because traditional models are monolithic streams, identifying and correcting that fake citation forces a full 50,000 token document regeneration. The sauce providers billing you for this compute effectively profit from their own model's mistakes. They're charging you over and over for the 99% of the output that was already perfectly fine. It's a pretty wild business model when you really think about it. Section 2, the sin of autoregression.
So the crucial point here is that we need to shift our entire paradigm about hallucinations. Hallucination is not a bug in the code. Actually, as the research points out, it's an inherent mathematical feature of the softmax function used in probabilistic generation. Large language models are autoregressive. They simply calculate the probability of the next word based on the previous words. They don't actually know the specs for a specific card dimension. They're just guessing the characters that are statistically most likely to follow. To make this perfectly clear, contrast these two concepts: autoregressive generation versus deterministic integrity. Think of it like comparing a student taking a math test by blindly guessing a formula based on what vaguely feels right, versus a student who is allowed to open a textbook, find the exact formula, and copy it directly onto the page. Traditional models are the guessing student. Landry argues that for immutable strings like URLs, specific measurements, and technical data, we absolutely must empower the AI to act like the student with the textbook. Moving on to Section 3, the copy-paste protocol. Now, what's really interesting about this proposed solution is the pointer generator architecture. Instead of generating text character by character and risking a hallucination, the model recognizes when a concrete fact is needed and literally switches into copy mode. It bypasses the softmax guessing game entirely. It extracts the information bit for bit from a verified database, a golden record, like a secured Google Drive folder, by using tools like Vertex AI context caching to pull the exact text rather than computing probabilities. It treats that piece of information as an immutable constant, not a variable to be guessed. Section 4, surgical token patching. Landry calls this specific mechanic the spy master logic. Instead of treating a document as one long linear stream of text that has to be rewritten from start to finish, the protocol treats the document as an addressable node map. Using tools like the Google Docs Batch Update API, the system observes the text, searches for a specific target key, pinpoints the exact start and end index range of the error, and surgically injects the correct payload. It just deletes the bad tokens and inserts the good ones at those exact coordinates. The rest of the document remains entirely untouched. It's brilliant. Section 5. Neurosymbolic logic gates.
Let's move on and see how this builds a deterministic failsafe. To prevent probabilistic drift, the protocol employs a secondary symbolic reasoner. You can think of it as a gatekeeper. Every single piece of neural output is checked against a truth table, a symbolic knowledge graph. The protocol uses cryptographic hash verification to compare the AI's output against the source document. If the AI's generated output contradicts the truth table, boom, the gate slams shut. The hallucination is instantly blocked, and the deterministic, 100% verified fact is automatically inserted instead. Now, of course, any new architecture has vulnerabilities, which Landry addresses with this threat and risk assessment map. Like, what if we become overly reliant on Google or Microsoft APIs to manage these surgical patches? Well, the mitigation is the local symbolic logic gate, ensuring the verification can happen entirely independently. Or what about bad actors trying adversarial prompt injections to break the pointer mechanism and force a hallucination? The protocol actually stops this by restricting the data pathways strictly to hard-coded JSON schemas. It surgically navigates these technical hurdles with just incredible precision. And finally, Section 6, Post-Predatory AI Economics. And this brilliantly illustrates the ultimate payoff, a 99.8% efficiency gain, because we're no longer forcing the model to regenerate a 50,000 token document just to fix a single erroneous citation. The computational load absolutely plummets. To patch a document using Landry's API coordinates, you might only pay for one single token, plus a tiny bit of metadata overhead. You have effectively decoupled the computational cost from the total document length. That is a real game changer. This directly connects the technical achievement of the code to Landry's broader vision of regenerative computing. She writes, "For the organic revolution of 2030, we require tools that respect the Universal Declaration of Organic Rights, meaning data must be accurate, traceable, and non-predatory. By eliminating the token tax and the massive energy waste of redundant compute, which shift from an extractive model of AI consumption to one that is highly efficient, deterministic, and above all sovereign." So what does this all mean for us? I want to leave you with this final provocative thought. As we scale AI to handle increasingly massive global infrastructures, can we really sustain the environmental and economic burn of autoregressive guessing? Or is a deterministic shift, where facts are facts and compute isn't wasted, the absolutely essential path forward into a post-predatory era of AI? It's a massive question about data sovereignty and ecological impact that affects every single one of us. Thank you so much for exploring this protocol with me today on The Explainer. Keep learning, keep asking the big questions, and I'll catch you in the next one.